Hello and welcome to this video on HVAC Loads and Zones, another beginning level video in our series at MEP-Precon.com. My name is Ken Dykman, and this is designed for newcomers in the industry to get you up to speed as quickly as possible to become more valuable to your employer and to customers. If you found this on YouTube, make sure to hop over to our website to take the assessment at the end of this to test your learning. Okay, let's jump into this then. So objectives of this video is to just understand what HVAC loads are, where they come from, what contributes to loads, and then we're going to distinguish between peak loads versus energy usage, for instance, annual energy usage, and then talk about zones, what an HVAC zone is, and how you might go about zoning out a floor plan. So what is an HVAC load? When you hear that, what do you think, what comes to mind when you think of that HVAC load? Well, it's basically, any demand on comfort, anything that prevents the interior space from being comfortable. So there's heating loads and then there's cooling loads, things that prevent you from being comfortable because it makes the space too warm, in which case that's a cooling load. We need to overcome it with cooling, and then the same thing for heating. So here's a list. It's not a completely exhaustive list, but it covers probably 80% of the different aspects that could interfere with creating a nice cool environment. These things would all add heat into an interior space, and so these are demands on cooling, and so we have to overcome all of these with air conditioning equipment, some type of cooling equipment in order to be comfortable. And then essentially we would go and calculate the amount of heat that all of these contributes to that zone, and we would come up with a peak amount of load that we need to overcome. That would be our design case or design load. That's what we would design our equipment for. Heating loads are a little bit simpler. There's, not a whole lot of things that contribute to a demand on heating other than just plain old heat loss in a building. I mean, because think about it, everything else in the building really produces heat, and we have to overcome it with some type of cooling equipment. The only thing that really prevents us from being comfortable in the wintertime is heat loss. So we want to make sure we have a good, well-insulated building to prevent that heat loss. But still, we're going to have some heat loss no matter how well insulated it is. And so we calculate that heat loss and we overcome it with heating equipment of some type. And so we calculate that, and that would be the worst case, the coldest time of the year. That would determine our peak heating load, and that would determine the size of our heating equipment. So not just insulation, but you could also have air leakage when the doors are open, if you have cracks around doors and windows and so forth. Okay, and then let's talk about how you'd calculate the load from a block standpoint or an overall building standpoint versus a zone standpoint. So a block load is essentially an overall building load without a whole lot of consideration of what's happening between adjacent rooms, heat transfer between those walls, that way in between the zones, in individual zones within a building perhaps. And so sometimes, for high level, if you're working with a customer and just from a high level, they might want to know how many tons this building will require. Oftentimes you could square foot it and say, well, it's going to be 350 square feet per ton overall. And so the whole building divided by 350 square feet, and that's how many tons you could say from a really high level, just from a rough order of magnitude standpoint. But then when you really go and zone the floors out and have individual pieces of equipment for each zone, that's where the calculations come a lot more detailed, and you find out the individual loads of each zone, and when you sum that up, oftentimes it is more than the total block load of the whole building. And then depending on what kind of equipment you use to serve the whole building, sometimes you can take some diversity in your equipment because not all zones are going to peak out at the same time. And so if you have a big central piece of equipment, you can downsize that a little bit to take advantage of diversity and not pay so much in upfront capital cost because, again, not all of those zones are going to peak out at the same time. And we talked about diversity. All right. Now let's talk about the difference between peak load versus energy use. So in energy analysis, no matter what your peak load is throughout the year, that happens at kind of an instantaneous time, maybe for a couple minutes or something. Everything else in the year, you're going to be off that peak load. So for example, for a cooling load peak, that might peak out at, say, August 15th at 4 o'clock in the afternoon when you have a ton of people in the space and they're using computers and all the lights are on. That would be the very worst case peak load. That would be what your equipment is sized for. Everything else, if it's in April or October, if there's not that many people in the space, the equipment's going to cycle on and off. It won't be running at its full max. So that's kind of the definition of the peak load. And then energy use throughout the year, again, no matter what size your equipment is, that's basically how often the equipment runs throughout the year. So every time it runs, every time, for example, that compressor runs when you're trying to provide cooling, that requires a lot of energy and it cycles on and off. But when it cycles on, it's pulling a lot of energy from your meter there, causing, a big electric bill. And so there's complex programs that basically calculate when that equipment is going to run throughout the year, again, no matter what size it is, and then it sums it up over the whole year through the different seasons, and that tells you how much energy use you're going to have. So energy use is different than the peak energy load or demand, which is what the equipment is sized for. Okay, let's talk about zones. HVAC zone. What is an HVAC zone? Well, it's a unique area of temperature characteristics. That is, it's an area that behaves similarly from a loading standpoint and being able to overcome it with heating or cooling equipment that way. It's based on occupancy. And so, for example, there might be some areas with some closed-in offices and some areas within a commercial office space building anyway, you might have some areas of open cubicle space. So those would be different zones. Maybe you have a conference room. And so that is a very transient type of occupancy space where you could have a lot of people in there at a certain time during the day, and then perhaps the majority of the time you don't have anybody in there. It's also based on the exposure to the outside. And so as you can imagine, a south-facing, depending on where you live in the world here, I'm going to talk about the northern exposure, which most of the US would be considered this here, where the south side of your building is going to receive a lot more sun or solar load, the heat from the sun entering the windows and hitting that wall, than on the north side. And so you'd have different zones on the south side versus the north side because they behave differently. The south is unique from the north side. The north, there could be times in the year that the south side requires cooling most of the day, while the north side requires heating most of the day, just because the north side might have heat loss and that south side or west side, as the sun comes around too, would have a lot of cooling load from that sun entering the windows and the walls. So let's look at a typical floor plan, and how would you think about the loads in this space, or not the loads, but the zones? Let's say that north is up in this space here. So this looks like a floor of a typical office building. And so there's a few conference rooms. There's some conference rooms here. There's some closed-in offices, and then there's some open offices. Well, if it's a big enough floor plate, for sure, you would definitely want to have at least 4 zones, one per exposure. You got a north exposure, an east exposure, a south exposure, and a west exposure. And as you can imagine, as the sun comes up and comes around the building here, it's going to create different loads on the building at different times here. So when it comes up in the morning, it's going to heat up this side, and gosh, this west side isn't going to feel any effect of that whatsoever until the sun comes around till about noon, 1 o'clock or so, and then the sun's going to hit this side. Now, by that time, the air is going to heat up a little bit, and so you're going to have a little bit of just load from having a warm wall, essentially. But now you've got the sun's rays actually going through the windows too, and that's going to heat up this west side. And then the south side might see that sun all day long. And then the north side, like we talked about, may never see the sun all day long. So at least 4. And then it's a good idea to, especially if you have closed-in offices like right here, is this a east zone or is it a north zone? Well, it's kind of both, isn't it? So ideally, that has its own area that you can treat with a piece of equipment. Let's say this is it doesn't matter, it could be a VAV, variable air volume system, or a fan coil unit system. So that would have an individual fan coil unit or a VAV box to serve that area. That would have its own thermostat in there. So, the number of zones correlates to how many thermostats you have. Each individual zone would have a thermostat that senses the temperature in that area, and then it just reacts with heating or cooling just for that area, just for that zone. So that's a good idea to have corner zones have their own thermostat because they have 2 exposures, and it's kind of hard to accommodate 2 exposures when that thermostat is somewhere else perhaps. And then conference rooms, here's some big conference rooms here. So would you have one big zone for all 3 of these conference rooms, or would you have 3? Well, ideally you'd have 3, but this is the art in trying to accomplish the balance between economy and comfort for an HVAC engineer. And if you're going to be selling tenant improvements, this is a real art, and you want to make sure to communicate this with your customer as to how many zones you have, maybe even provide a zone map with your proposal to show your thought process of how you're going to zone it out. Because as a mechanical professional, if you send in your proposal to your general contractor without giving them that information, they may not have any other information to go off of other than price to make a decision. So you want to educate them to say, hey, I think I have the best combination for zoning here, zoning given, economies. But if your customer is really concerned on comfort, we might want to add, a couple of more zones. So maybe you've assumed 1 zone for this whole space. You can say, it really requires 3 zones, but I know that cost is an issue for this owner, and so that's why we made that decision. Just basically make sure that you communicate that, because if you don't, they may take someone else's number who haven't communicated that same information to them, and then they might be uncomfortable at the very end, and you're stuck with your customer holding the bag with their owner saying, gosh, what did you do to me here? I'm really uncomfortable. And then it's just kind of a lose-lose situation for everybody at that point. It's economical, but the owner or somebody's going to have to pay to come back to put in some more zones later because that zoning plan wasn't communicated very well all the way up to the owner to be made aware of there might be comfort issues, or do you want to pay a little bit more money now to make sure that you're comfortable. Here's an interior conference room here that might dictate its own zone. So essentially, if on the exterior we talked about the exposures here, if you can cover the outside with a particular zone, so this is a big cubicle space down here. it wouldn't be too much of a problem to handle this whole south side with one, either a fan coil unit or one big large VAV box. And if you could do that, then about 10 or 15 feet in from the perimeter, that's all going to be an interior zone. That's not going to feel any heat loss whatsoever. So that's always going to require cooling. So you'll have some interior zones and you could have some exterior zones. But they're separated by unique areas, again, by exposure, by occupancy, closed-in offices. Could you put closed-in offices with open offices? Not a good idea, but again, given the economy and if you have to compete with people, you know, generally people in cubicle space, they're probably generally not as important as people in offices. So you'd probably find a thermostat in someone's office, and then the air out here would just come along. Just, you know, whatever's happening within here, the air out here is going to just come along for the ride, basically. So the more zones you have, obviously, the more comfortable it would be, but it's also more costly. Tons of more information out here by different people that have different opinions, but a lot of it's just experience, knowing your customer, knowing the owner, and their tolerance to comfort. All right. So considerations about zones is make sure that you consider the building standards. There are several big companies that might have hospitals, for example, too, medical office buildings that might have certain standards of no more than 3 closed-in offices on a thermostat, or no more than 800 square feet per zone, something like that. And then be careful about code considerations. There might be, in your area, there might be requirements that conference rooms or any areas that, for example, might have more than so many people per so many square feet, you know, 25 people per 1,000 square feet or something, would require separate zoning, or you might have to have a CO2 sensor in there to make sure that it senses CO2 buildup. And that's a good thing. So in conference rooms, you know, if there's nobody in a conference room, well, let's not provide a bunch of fresh air in there to heat and cool all that fresh air. If it's cold outside or if it's hot outside, let's close that down. But if it senses there's a lot of people in there, not just an occupancy sensor, you know, a CO2 sensor would do something different than an occupancy sensor. An occupancy sensor would sense if there's one person in that conference room, but a CO2 sensor wouldn't change much if there was 0 or 1 person in there. But if there were 15 people in that conference room, it would react differently. It would bring in more fresh air that way. So considerations from an energy standpoint that way. The number of zones that you have are easy to use for cost cutting if your customer just has some really tight budgets that, you know, need to be adhered to. Just make sure that you communicate that, because once they're in there and once they're uncomfortable, it's really costly to come back and remobilize and add zones later, depending on what kind of system it is. If it's a VAV system, that's not too hard to retrofit, but any type of hydronic system, a fan coil system, either a 2-pipe or 4-pipe fan coil system, or a water source heat pump system, could be pretty costly just because it's not as easy to cut into water pipe as it is with an air pipe, like a VAV box system. So just qualify that in your proposal and discuss. Try to discuss that in person if you can. Build that rapport with your customer and let them know, you know, how much you care, and just have that dialogue back and forth as to what zones, what people, and what offices might be most important to have your zones and your thermostats. And that's it. Relatively short video, and so I encourage you to research other sources as well to make sure you get these concepts, and make sure you jump over to our website if you found this on YouTube. Again, look for that assessment and score 100% on it. If you didn't, come back and just fast forward, move the slider to the areas that you need to review again, perhaps to get 100% on that assessment. If this video is something that you wanted to incorporate at a larger scale in your company, then reach out at MEP-Precon.com and let's discuss virtual or in-person training on this and plenty of other subjects. And be sure to check back here often for more videos that we'll be adding all the time. Thank you.